Hi team. Okay, so we're going to try something new. I'm going to record me going through this exam and we're going to see if it works. If it doesn't, my apologies. Okay, I've done a bit of this already to start with. Now, number one, not bad attempt on this from what I've seen so far. So again, I cannot stress this enough. I don't know how many times I've said it. When you have something where they are taking several readings, there we have several points. Why are they doing that every time? It is to reduce the effect of random errors every single time. I don't know what I'm going to have to do to get people to start remembering that, but this is the answer. Also, you can say to find anomalies or to be able to calculate a mean. You can also, if you do say to calculate a mean, you can also say to improve accuracy or make it more accurate. So by taking multiple readings and taking a mean, you are going to get a more accurate value. Not enough to just say make it more precise, not enough to say to reduce human error or any of those things that you say. This is the big one, the top one, to reduce the effect of random errors. Please remember that, okay? Whenever there's somebody taking several readings, that is the reason why. The next one is to find the percentage uncertainty. Now, again, we've got multiple readings, and to get the uncertainty in multiple readings, we have to do half the range. So we find the range, which is the biggest value. There's the biggest value, take away the smallest value, and then divide it by 2. Now, if you do that, you get 0.085. That's here. That is your absolute uncertainty. Uncertainty here. So don't get confused. I think somebody I saw, got a little bit confused between what this value was and the percentage uncertainty. So to go from the absolute uncertainty to the percentage uncertainty, we need to do, remember, percentage uncertainty, what do we call it? We call it sigma, don't we? So the percentage uncertainty is the absolute uncertainty, what we were measuring here, W, divided by the mean value. Okay, so first thing we have to do is we have to find the mean. So you add them all together and divide by how many there are. If you do that, you get an answer of 7.15. And then we're going to do the absolute uncertainty divided by the mean multiplied by 100, and you get an answer of 1.2%. Okay, so I think most people got that, but it was a little bit ropey. I know it's been a while since we've gone over that, but please remember this process for finding the absolute uncertainty when you've got multiple readings. Okay, the next one. This was not brilliantly done. So we're given this area and what compared to the value for W, which we calculated earlier. Now, if you think about it, I've drawn on the left-hand side here a kind of a representation. The area, let's see, so, drawing a different colour. So this area here is this one. So they give us that. The cross-sectional area of the whole pencil is given by 0.83 times W squared. And then what we're told is that the volume of the cylindrical core is known to be 9% of the volume of the whole thing. Now, if the volume of the core is 9% of the whole area, then the area of the core must be the 9% of the whole area. And the reason for that is because the length of the pencil is the same for both of them. So hopefully that makes sense. To get the volume of the pencil, you're just going to do however big the area is. So looking over here on the left, so the area of the core multiplied by the length of the pencil, that's going to give you the volume of the core. If you do the area of the whole pencil multiplied by the length, that's going to give you the volume of the whole pencil. But both times the length is the same. It's a constant factor, and so it's just going to cancel out, so it doesn't matter. So really, all we're doing is comparing the two areas. So to write this down, to capture what they've told us upstairs here, the volume of the core, so that's the central bit here in red, is 9% of the volume of the whole pencil. So what we can do is we can say the area of the whole pencil, so that's here 0.83 w squared, times 0.09. That 0.09 there is going to give us the 9%. Multiplied, so 9% of the whole pencil is going to give us the value of the core. And for this, I've just done the area of a circle, pi d squared over 4. So you're used to seeing pi r squared, but of course that's equivalent to pi d squared over 4, where r is the radius and d is the diameter. So that's obviously very simple to solve. You get a value for d, which is, hang on a minute, let me find it. So, okay. Oh, it doesn't actually give us the answer, so I'll have to calculate that in a moment. Yeah, I'll do that in a sec.